In this video, we will discuss about how to draw the ray diagrams in spherical mirrors, that is the convex and concave mirror. Before drawing the ray diagrams, we have to keep in mind some of the rules for drawing these ray diagrams. First of all, if the incident ray passes parallel to the principal axis, the reflected ray will pass through the focus. Number 2, if the incident ray passes through the center of curvature, it will retrace its path. Number 3, if the incident ray passes through the focus, the reflected ray will pass parallel to the principal axis. Number 4, if the incident ray strikes the mirror at the pole, the reflected ray will pass maintaining the law or obeying the law of reflection, that is, the angle of incidence will be equal to the angle of reflection. The first diagram, when the object is at infinity. First of all, see, we are taking a straight line and dividing the straight line into 4 equal halves. Okay, see, we are taking the points at 0, 2, 4 and 6. Now we are drawing the straight line. Now the point at which we are placing the compass, okay, that's the center of curvature. Okay, now see, we are pointing the compass to draw an arc. Okay, now see, we have drawn this arc. This is the mirror, this is the concave mirror. Okay, the point at which we have placed the compass, that is the center of curvature, and the distance between the center of curvature, that's the relation basically. Now see, we have drawn the focus and the pole. The distance between pole and focus is equal to the distance between focus and center of curvature. Now we are drawing the first incident ray that is parallel to the principal axis, which strikes the mirror. Okay, and this is our second incident ray, which is also striking the mirror, and it's parallel to the principal axis. So according to the law or the rules, we know if the incident ray passes parallel to the principal axis, the reflected ray will pass through the focus. Now see, we are drawing the reflected ray that is passing through the focus. Okay, this is the first reflected ray, and now we will, this is the very important thing, that is the arrow. Unless and until you give the arrow, the ray diagrams will be wrong. Now this is our second reflected ray that's also passing through the focus. Now see, we are drawing the reflected ray for the second incident ray. Okay, that is passing through the focus. An arrow diagram is must. Okay, so this is our ray diagram for the object which is at infinity. Now we are naming the incident rays, that is AD is one incident ray and BE is the other incident ray. So this is all about the ray diagram for the object at infinity. Now we will be discussing about the characteristics of the image formed by this concave mirror when the object is at infinity. Now, number 1, it's real image. Why real? Since the object and image are on the same side. Okay, now number 2, the image is diminished to a point. See, the image has formed just like a point, so it's diminished. 3, the image is formed at the focus. Okay, so this is all about the characteristics of image. Now we will be moving forward to our next diagram, that is when the object is at far distance. Now see, just like the diagram we have drawn before, we are dividing the line segment into 4 equal halves. We are taking the point 0, 2, 4 and 6. Now again we will place the compass at the center of curvature to draw the arc. The arc is the mirror. So we have drawn our concave mirror. Now we are pointing, that is the center of curvature, this is the focus, and this is our pole. Okay, now we are taking our first incident ray, okay, that is striking at the pole. See, we are pointing the pole, and now we will draw the ray diagram, or the incident ray basically. This is our incident ray, just this is our incident ray, okay, that is striking the pole of the concave mirror. Now as we know the rule for drawing the ray diagram, that if the incident ray strikes the mirror at the pole, the reflected ray will get reflected obeying the law of reflection, that is the angle of incidence will be equal to the angle of reflection. Now this is our second ray, that is also striking the mirror at some point other than the pole. Okay, now again we are drawing the reflected ray, maintaining the law of reflection, that is the angle of incidence will be equal to the angle of reflection. Just see, we are drawing the reflected ray. Okay, this is our second set of incident ray and the reflected ray. Now just see, both the rays are intersecting at the point and where the image is formed. Okay, now again the most important part of the ray diagram, that is the arrow. If you miss the arrow, you will miss the marks. Okay, now this is the ray diagram for the object at far distance. Okay, now we are naming the image, that is A1, B1. We cannot see the object since the object is at far distance. Now we will talk about the characteristics of the image formed at far distance. Now, number 1, the image will be real. Same reason, since the image and object are on the same side of the mirror. It is inverted. You can see that the arrowhead is downward, that is the image is inverted. Now the third point, that is the image is highly diminished, okay, as of the object. Now the position of the image, now we will write the position of the image, that is the image is formed in the focal plane. Okay, so this is our characteristics of the object is at far distance. Now we will move towards our third ray diagram when the object is beyond the center of curvature. So see, the same thing we are repeating. We are dividing a line segment into 4 equal parts. Now we are joining the line. Okay, see, as earlier we will place the compass at the center of curvature to draw an arc, and which is our concave mirror. So this is our concave mirror. Now this is the center of curvature, this point is our focus, and this will be our pole. Now we are drawing the object. See the position of the object, that is beyond the center of curvature. So this is our object. Okay, now we will draw the incident ray. We are pointing the head of the object. The arrowhead is the head of the object. Now the first incident ray, see, we are drawing the first incident ray that will pass through the center of curvature. Okay, the incident ray is passing through the center of curvature. Now this is our second incident ray that is passing parallel to the principal axis. Okay, now according to the rule of ray diagram, if the incident ray passes parallel to the principal axis, the reflected ray will pass through the focus. Now see, we are drawing the reflected ray which is passing through the focus. Okay, the second the second reflected ray is passing through the focus. Now the main part, that is the arrow. Just see, in case when the incident ray is passing through the center of curvature, the reflected ray is retracing its path, that is, it is returning through the same path. Now see, the two reflected rays intersect at the point, and that will be our image. Okay, the object is named as AB and the image is named as A dashed B dashed. Okay, so this is the image formed by a concave mirror when the object is beyond center of curvature. See, AB is the object and A dash we have already said earlier, and A dash B dash is the image. Now the characteristics. Now we will write the characteristics of the image formed by the concave mirror when the object is at beyond the center of curvature. Number 1, it's real since the object and image are on the same side. It's inverted. See, the arrowhead of the image is in downward direction, whereas the arrowhead of the object is at the upward direction. So it's inverted. The image formed is diminished. That is, the size of the object is larger than that of the image. Now the position. The image is formed between the center of curvature and focus. So this is the position of the image. See, it is the position where the image has formed. This is all about the characteristics. Now the fourth one, that is when the object is at the center of curvature. Okay, same way we are dividing the line segment into 4 halves. Okay, now we will place the compass at the center of curvature to draw the arc. That's our concave mirror. Okay, now this point is our center of curvature, so the object is at center of curvature. Okay, so now we will draw the object that is at the point center of curvature. This is the arrowhead, is the head of the object, that is the top of the object. Now the first incident ray, we will draw the first incident ray that is parallel to the principal axis. This is parallel to the principal axis, and the second incident ray, now we will draw the second incident ray that is passing through the focus. Just see, the second incident ray will pass through the focus. This point is our focus, and the second incident ray is passing through the focus. Now according to the rule of ray diagram, if the incident ray passes through the focus, the reflected ray will pass parallel to the principal axis. Now see, this is our reflected ray, okay, and when the incident ray passes parallel to the principal axis, the reflected ray will pass through the focus. So now see, we will draw our reflected ray that is passing through the focus. Okay, now just see the two rays. This is our, just see, the two reflected rays are meeting at a point or intersecting at a point where the image is formed. Okay, now the main part or the most important part, the arrow are the most important part for the ray diagram. Okay, so now we will name the object as well as the image. So the object is named as AB, whereas the image is named as A dashed B dashed. Okay, just see, and this is the point center of curvature, this is the focus, and this is the pole. So this is the image formed when the object is at center of curvature. Now we will discuss about the different characteristics of the image that is formed when the object is at center of curvature. Now, first one, the image is real. Why real? We know, since the object and image are on the same side of the mirror. It is inverted. You can see that the arrowhead in case of the image is in downward direction, so the image is inverted. Okay, just see, A and B, and the image is A dash B dash. The image size is same. Okay, the image size is same as that of the object. Okay, so these are the three characteristics, that is, the image is real, it's inverted, and it is same size as the object. Now the position of the image is formed at the center of curvature. Now the next one, when the object is in between the center of curvature and the focus. Now see, similarly we are dividing a line segment into 4 equal halves as earlier. This is basically done to maintain the relation between the focal length and the center of radius of curvature rather. Now see, again we will place the compass at the center of curvature to draw our concave mirror. So this is our concave mirror, and the object is in between center of curvature and focus. So we have made our center of curvature and the focus as well as the pole. Now see, this is our object. Just see the position. The position is in between center of curvature and focus. The arrowhead denotes the head or top of the object. Now the first incident ray is basically parallel to the principal axis. Okay, so according to the rule of ray diagram, the reflected ray will pass through the focus. Now see, this is our reflected ray that will pass through the focus. So this is our reflected ray. Now the second one, that is, the incident ray will pass. Just see, the incident ray will pass through the center of curvature. Just see, this is our center of curvature and the incident ray is passing through the center of curvature. So this is the second incident ray that is passing through the center of curvature. And as we know that when the incident ray passes through the center of curvature, the reflected ray retraces its path, that is, it returns following the same path. So just see, when the incident ray is passing through the center of curvature, the reflected ray is following or returning through the same path. Okay, this is the ray diagram, and see the image, the position of image. This is the image formed. Okay, now just see the two reflected ray. The two reflected rays are intersecting at this point. Okay, so the object is named as AB, whereas the image is named as A dashed and B dashed. Now the characteristics of the image. Okay, the characteristics of image when the object is in between the center of curvature and focus. Number one, it's real, since the image and object are on the same side of the mirror. It's inverted. You can see the arrowhead of the image is facing downward. Okay, now the third one, that is, the image is magnified. You can see the size of the object as well as the size of the image. Okay, that's the size of the object is smaller than the image, that's why the image is magnified. Now the position where the image is forming, just see, the image is formed beyond the center of curvature. Okay, beyond the center of curvature. So these are the characteristics of the image when the object is in between center of curvature and focus. Now we are moving towards our next ray diagram, that is when the object is at focus. Now the same thing we are repeating. We are dividing the line segment into 4 equal halves. Just see, these are the 4 points, that is at 0, 2, 4, that is we are taking equal distance of 2. Now we will place the compass at the center of curvature to draw our concave mirror, and this is how our concave mirror forms. So we have got our center of curvature and focus. This is our pole. Now the object is at focus. We will draw the object at the focus. This is our focus, and this will be our object. Now see the arrowhead that denotes the top or head of the object. Now the first incident ray will pass through the center of curvature. Just see, we will draw the first incident ray which is passing through the center of curvature. This is the incident ray, and as we know the rule of ray diagram, that if the incident ray passes through the center of curvature, it retraces its path. So we have also got our reflected ray for the first incident ray. Now this is our second incident ray, that is parallel to the principal axis. Now by following the rules of ray diagram, the reflected ray is passing through the focus. Just see, the reflected ray is passing through the focus. Okay, now the most important part, the arrows. Okay, see, the incident ray and the reflected ray, in case of the first ray, when the incident ray passing through the center of curvature, just see the arrowhead, the reflected ray is retracing its path, so we cannot see the image, as because both the reflected rays does not intersect at any point. Now this is our object, that is AB, and we are not getting, or we can't see the image formed in this small bit of paper. Now this will be the characteristics. So the characteristics of the image formed the characteristics of image formed when the object is at focus. Number one, it's real. Same reason, the image and object are on the same side of the mirror. It's inverted. The image is inverted and it is highly magnified. It's highly magnified. That's the size of the image is much bigger than the size of the object. Now the position. As we can't see the image in this small bit of paper, that means the image is formed at infinity. Okay, so this is the position of the image. Now we will move ahead to our next diagram, that is when the object is in between the focus and the pole. Similarly, just see we are dividing the line segment into 4 equal halves. Okay, now here we are dividing it into 5 equal halves. Okay, now this is our pole, this is focus, and this is our center of curvature. Now just see, we are placing the compass as before in the center of curvature, at the center of curvature, sorry, and this is our concave mirror. Okay, now just see, the position of the object is between focus and pole. So this is our object that is placed in between focus and pole. Now we will draw our first incident ray that will pass through the center of curvature. So this is our center of curvature and the first incident ray is passing through the center of curvature and the reflected ray is also retracing its path. Now we will draw the second incident ray. Okay, a pair of incident ray is always better for drawing the ray diagram. So this is our second incident ray which is parallel to our principal axis. Now following the rule of ray diagram, the reflected ray will pass through the focus. So this is our focus and the reflected ray will pass through the focus. Okay, so we are extending the line. Why we are extending the line, you will understand. We are extending both the reflected rays. Now just see, we are extending, that is we are drawing the dotted line to denote this extended line. Okay, you can see that both the reflected rays meet at a point beyond the mirror. Okay, so this is the point of intersection of both the reflected ray and the image is formed at that point. Okay, so the image is named as A dash B dash and the object is named as AB. So you can see that the image is formed beyond the mirror. So now we will discuss about the characteristics of the image when the object is placed between the focus and the pole. First of all, now here comes a difference, that is the image is virtual because the object and image are on the opposite sides of the mirror, and you can see that the image formed is upright. Why upright? Because the arrowhead of object as well as image are both directing in the upward direction. The image is magnified, that is the size of the image is larger than that of the object. The position of the image, you can see that the image is formed behind the mirror. Okay, so this is all about the characteristics of this ray diagram. Now we will draw the object that is in a convex mirror. So far we are drawing the ray diagram in a concave mirror. Now we will draw the ray diagram in a convex mirror. Okay, so we are dividing the line segments and we are drawing the principal axis. Now we will place the compass at the center of curvature. We'll place the compass at the center of curvature to draw our convex mirror. So this is our convex mirror. Okay, now we will draw the object in front of the mirror. So now we are drawing the object. We are taking the object in front of the mirror. Just see. So this will be our object. Okay, and this is the arrowhead that denotes the head of the object. Now the first incident ray will pass through the center of curvature, and just see that we will draw a firm line till the mirror. Okay, and then we will extend the line up to the center of curvature in dotted line. Okay, because the incident ray is striking the mirror. Okay, now the second one. Okay, you have just seen that when the incident ray is passing through the center of curvature, the reflected ray, as earlier, is also retracing its path. Now the second one. Okay, just see, the second one is parallel to the principal axis. So according to the rules of drawing the ray diagram, the reflected ray will pass through the focus. Just see, the reflected ray is passing through the focus. And why we are drawing the dotted lines? So this is not the real one. Okay, so it seems to be passing, or it appears to be passing from the focus. Okay, just see, now the two reflected rays intersect at a point where the image is formed. The object is named as AB, whereas the image is named as A dash B dash. That's our pole. This is the center of curvature, and this is the focus. So this is how the image is formed. Now the characteristics. We will see the characteristics of image of the object in a convex mirror. Number one, the image is virtual. You can see that the position of the object and image are on the opposite sides of the mirror. The image is upright or erect because the arrowhead of both the object and image are in upward direction. It's diminished. You can see the size of the object is much larger than the size of the image. That's why the image is considered to be diminished. The position of the image, where the image is formed. You can see that the image is formed between the focus and pole. Okay, between the focus and pole, but on the other side of the mirror. So these are the characteristics, and these are all the ray diagrams by the spherical mirror. Thank you.